when I see things from like the Tesla Optimus robot, their like cyber cafe thing. That's just and the thing that strikes me most is the pace of evolution. I started that product in 2023 and then pulled back from developing at the end of beginning of kind of 24. And the reality is that year, everything had fundamentally changed. And I think we're seeing these innovation cycles and these capability leaps happening ever increasing rates now. And I work in the space, so I'm constantly up to date with the news, and it's just drinking from a fire hose consistently.
Welcome to the Dev Ready Podcast. Joining me on the Dev Ready Podcast today, I have Alexander Cohen. Alex, thanks for taking the time out of your day to have a chat today.
Thanks for having me. It's exciting to be kind of talking on AI and robotics and just sharing what we're doing with everyone.
Yeah. I haven't had many chats on robotics, so this will be an interesting one today. All I know about you is that you're a sort of community leader in AI up in Brisbane, but I'll let you introduce yourself because that's how I do things for those of you that don't know how the podcast runs. I've never actually met Alex before, and this is the first time we're having a chat. So I'll let you take it away.
Well, thanks for reaching out on LinkedIn, and big fan of what you guys do with the podcast. I'm Alexander. I run an AI consultancy here in Brisbane, but I also run the Brisbane chapter of the Queensland AI Hub, where we advocate for AI adoption and just help everyone kind of understand the technology. Last year, we ran about 40 public events and worked with thousands and thousands of people to bring AI technology into the forefront of their capability set. But I've kind of found myself at this weird place, and it's interesting that you reached out while I'm building a robotic kitchen, because for background, I'm not a mechatronics engineer. However, AI has enabled me in the last 6 weeks to deep dive into this tech. So there's a lot to unpack today, and I'm sure it's going to be an interesting discussion.
So being part of sort of the AI hub there in Queensland, was this pre-ChatGPT and like traditional AI, or is it just more like LLM focused?
I've been working with and playing with AI since 2015. Some of my early stuff was like Batman, not Batman, image classifiers, very crude PyTorch and Python kind of workbooks in my home studio setup. But no, I really got full-time into AI in 22 when I kind of identified the inflection point that happened in 2017 with the GPT transformer paper from Google DeepMind. Kind of now was when the technology was about to take off. So I've been in it full-time for the last few years and deep dived in quite a few areas of AI. Most of it is LLM based, but we are very quickly branching out to more traditional ML and machine learning concepts.
I think most things it's just the LLM based. How can you leverage it to get the most out of it to add it to a product? Yeah. Because that's almost effectively like the low hanging fruit. It's an API. It's easy to integrate. Everything else still needs time, and a lot of what you need to do in ML is sort of taken care of now. You don't have to do anything to do with text, which was probably one of the biggest spaces that people were working in, and then images on the other side.
Yeah, absolutely. I think the data side of machine learning is almost a solved problem. You can create synthetic data sets now. You can clean up data sets ridiculously quickly. We've kind of reached this inflection point where the challenges of 5 or 10 years ago around actually producing AI models, be it large language models or time series models or whatever kind of model you're looking for, the challenge and the barrier to entry is really plummeted. And I think you're right. There is such low-hanging fruit. And because we're at the beginning of this transformation of how AI is going to fundamentally change society, we all have this opportunity to kind of figure out how and where to apply these tools. And I'm constantly experimenting both with API-based AI and like we bought a couple of GTX Sparks, and then put them together and made a little supercomputer and just run local setup. So everything across the entire stack we've been playing with, and it's quite a lot of fun.
It is fun. It's a good experimental phase because there's a lot of unknowns. You don't know what you're going to get into. You're learning something new. So you might not know, we run a software product called DevReady AI, which is a platform I built which helps us design software spec.
Yep.
So you can plan it and understand what you're building. Before ChatGPT came out, we were looking at like, how do we build a model then to start classifying text? And the idea was we would go and scrape Facebook and all the big companies and go look at their fact pages and their how to use the systems, because then they'll tell us what use cases are in those software, and then we can use that to then guess what software might want in your software. Then ChatGPT came out, took a while, like a couple of weeks or a couple of months before I actually got like the gears clicked down and said, oh, this is a solved problem now. We don't have
Yeah,
to go
right.
down that path.
It's interesting. My first foray into the AI space was with a product called GoScope, and I think I was a bit too early to market. And it was, how can you take a non-technical person using AI and guide them through the product discovery and ideation process of like, what is the requirements and how do these requirements work together? I'm just thinking maybe I should revive it for internal use, but it's interesting what you can do now with AI systems, especially in that that kind of information gathering. One thing we looked at was not only looking at the specs and public documentation, but actually going to support forums and finding out where the bugs were and where the problems were and identifying opportunity there. Because if you've ever been on a support forum for Atlassian pre-AI, you just know where the hatred is of any given product. And so, yeah, it's really interesting to see how it's evolving. And the thing that strikes me most is the pace of evolution. I started that product in 2023 and then pulled back from developing at the end of beginning of kind of 24. And the reality is that year, everything had fundamentally changed. And I think we're seeing these innovation cycles and these capability leaps happening at ever increasing rates now. And I work in the space, so I'm constantly up to date with the news, and it's just drinking from a fire hose consistently. And I'm sure everyone else is experiencing a similar thing.
To me, it's more like those like spillways, and you see those dams that just jump out for about like a kilometer of water. I think it's
Yeah,
more like that than a fire hose. It's
tidal
so hard.
wave.
Yeah, it's so hard to keep up with what's happening,
Yeah.
and probably being a bit more in a different forefront as well, because you're in the robotics side. It's two streams you have to keep up with, because it's not just the AI, it's also the robotics and the hardware and what's possible, and new materials that are coming out as well.
Yeah, absolutely. I think robotics represents a really interesting kind of area for the next 5 years, because when you look at how AI is empowering computer systems from a software layer, and then you look at how robotics has matured over the last 20, 25, 30 years, we're now at this kind of inflection point where a lot of the limitations that previously held back robotics from accomplishing complex tasks was that reasoning and that real world sensing. And if you look at one company, just look at NVIDIA and what they're doing with robotics and the open source, everything available online for free. The things that are coming out of NVIDIA is unbelievable. These robots are first generation, just there's no sensors on them, it's all dumb. And using AI tooling, we were able to build an AI orchestration system. And just this morning, I was building a mapping tool where it would just gently bump into all the physical objects and build a three-dimensional map of its space. Things like this were not possible even 6 months ago. So I think the future is almost inevitable in terms of how AI and robotics are fusing together to create these incredibly sophisticated technology systems that don't just live in the digital world anymore. They can interface with real world. We're still a long ways to go by all means, but the pace at which it's changing is unbelievable.
It is. It's almost a bit frightening at times, especially when you see some of the robot demos. But then
Yeah.
you hear a few weeks later that the demos are staged, or there's someone in the back with a controller moving it around and doing stuff, and it's not exactly autonomous, or the AI is just like object recognition on the cameras. It's got nothing to do with actually controlling the robot.
This is where I take a lot of objection and a bit of a pause when I see things from like the Tesla Optimus robot and their like cyber cafe thing. That's just some guy in a VR headset in India or somewhere else, kind of teleoperating the robots. We've done it here with a G1. So
Yeah.
it's not a genuine reflection of where the tech is at. And I think there's a big problem right now with, because everything's so new and everyone wants to be first in the forefront and demonstrate credibility, the marketing hype is just out of control.
Yeah.
People are overstating what's possible and they're making promises they can never deliver on. And the marketing material is just, there's a material gap between what's possible and what marketing is saying it's doing. So I'm always a bit skeptical when I see these demos, and until I can physically play with the stuff myself, always a bit apprehensive about believing the claim.
Yeah, I think that comes down to probably the way I see it. There's two sort of classifications for the robotics industry. You've got the robots that just do a repeated task constantly, and that's what they're for.
Yep.
They don't need AI.
No.
It's repeated. You got coffee machines at shopping centers. The
Yep.
robot coffee. It knows where the milk is. It knows where the temper thing is. It knows. It's just a repeatable action over and over and over. It's just got parameters. Turn the milk for 1 second or 5 seconds, depending if they want a latte or whatever it may
That's
be.
it.
Like it's very repeatable, very done. Then you've got the full general autonomous house-made robot, which is what everyone's trying to sell. And we're not close to that at all. You're not going to be able to get from my understanding, the limitation is it's sort of like the fine motor control isn't there enough yet. So if you want it to fold your laundry, it's not going to happen. Cutting fruit and vegetables, it can do that because it's not that fine grained control where you have to be able to control the materials and move them around.
Yeah, I think there's a couple of key factors, and if we look at just the tech factors for a second, there's a big difference between simulated physics in a digital environment and real world physics. And I've been reading a couple of white papers where a bunch of simulation software predicted this outcome, and then scientists actually went and did the experiment, and the result was wildly different. So I think we're making a lot of progress collectively as a species towards mirroring the physics in the real world. But ultimately, there is so much variation. And for context, these opposable thumbs and fingers, this is hundreds of thousands of years of evolution to get the tactile control, the pressure sense. Like this is fine-grained evolution at its finest. And I think it's unrealistic for us to kind of say, oh, we can mirror this and everything you can do with it in a couple of years. Not to say we won't get there, we absolutely will. But today, I think we're still a ways off. And realistically, the rate that this thing is improving is pretty fast, but it's still not fast enough to deliver on what these humanoid robots, home assistants, are kind of claiming. And I think realistically, if we look at where the opportunity lies, is we're kind of creating machines in our own image, and that's great, but we have limitations as human beings. And for example, in our kitchen, this kitchen is laid out so that a person, if we took the robot out, a person could operate this kitchen no problem whatsoever. The downside of something like that is that robots can operate in a speed and a pace and with physics that humans cannot. This robot can move at 1,200 millimeters per second. Like that's astronomically fast. I can't move that quickly. And as a result, if we're constantly trying to have robots copy what humans are, we're just introducing the same limitations that humans have. So I actually see there being a bit of a divergence in robots with AI backing, where we'll get these environments where robotics is the core modus operandi, the way that things are done. So our goal with a kitchen is actually not to build it for humans, it's to build it exclusively for robots and maximize the efficiency that a robot exclusively could accomplish. But when we're trying to get the hybrid where humans and robots can collaboratively work on something or work in interchangeably, I think we're going to meet some of the same constraints that we as humans experience on a day-to-day basis.
I think you'd have to have those constraints because you're doing the handoff to a human.
That's it.
It has to be the equivalent amount of force that would be suitable for
Yeah.
a human, where if it's in a factory constructing something, it can do whatever it wants. You can use as much as possible to ensure that nothing falls. Even just rearranging the kitchen, if it's more like a sushi train model where the robot can move up and down in between a bay of things, that can be more efficient for the robot than something walking.
Absolutely.
Especially when you don't need a human to be in the loop.
I mean, even to take that even a step further, if we look at our kitchen, so in the back here, we've got some fryers. Now, those fryers are effectively just that top piece here. Everything else is void space, and there's a lot of empty space between the extraction fan and here. So if those fans aren't pumping air fast enough, the fumes go elsewhere, the vapor goes elsewhere. And so the reason, and if we go back to first principles, the reason that that's needed is because human beings can be burnt. And if you have hot oil at a height above the vital organs of your body and oil spills on you, you're now introducing a really serious health risk and a really serious injury. Robots, that thing, you can splash it with 200-degree oil and it won't matter. And so this is where the divergence, I think, will take place. Is we're looking at a future where we stack these fryers on the ceiling 10 stack tall
Yeah.
because there's no need for a human to be protected from oil coming down on them. So I think there's going to be that divergence between what's safe and what's applicable and what's usable. Humans have a great range of motion, but I can't lift something on my tiptoes reaching 2 meters in the air. Robots have no problem. This is the difference.
But do you also see that in that space, the AI is a little bit probably pushing too hard in the robotics? Like if you've got a proper kitchen set up with everything in the right place and the robot is programmed to know where everything is and what it needs to do, what you need, I don't think you need AI in that sort of scenario.
Yeah, I think from an operational perspective, potentially not. However, AI isn't just about moving the robot. It's also about how do you organize the
Identify.
tasks and sequence things. And this is where I think we've kind of diverged away from the LLM and kind of basic computer vision stuff to we've built an AI orchestrator where we give it a strategic goal, which is we need you to cook this meal. It knows the steps involved and it knows what equipment it needs to utilize. And then it figures out what is the best course of action. And instead of us programming a set path, we instead break it down into these atomic structures and say, well, this hot chips, a plate of hot chips and fish and chips is going to need a fryer, it's going to need a bowl, it's going to need a robot arm, it's going to need the fridge to dispense. So we essentially break each step down into its incremental part of what is required for that step and what is necessary for that step to take place. And this is where the AI really shines because it can do multiple simulations, multiple paths. It can look at all the different possible permutations. And more importantly, it can optimize for a certain outcome. If we want all the meals to arrive at the same time, it might do all the steps up until a certain point and then wait. And I think this is where if you optimize a space for robotics, you can start focusing on the tooling, at least from an AI perspective, on achieving things that you just could not do otherwise, and really getting a different outcome. So we're seeing AI being used in a very different way. But I mean, programming the robot, our long-term goal is to not actually program paths. It's just to say, hey, this is where this thing is. This is where this thing is. This is where this thing. You figure out how to go.
I guess there's probably a bit of a trade-off there to having some of it up to the AI to determine how to do everything, and then other bits of it set repeatable, so things occur. Because then you also got a time waste in the AI taking its time to calculate it, the energy cost in doing that as well. When it's something repeatable, it doesn't need to do that every time, and you want the same outcome effectively.
I don't know if that's a material factor at this point. Mostly because the robot's going to need instructions, and at the end of the day, these are complex but simple machines. Like there's just there's 6 electric motors in here, and there's a bunch of current that runs to those motors to tell it to turn on and off. And there is a computer that's running that, and that lower level gets abstracted up into here's some X, Y, and Z coordinates in 3-dimensional space that I want you to move to. And there's a basic mathematical calculation that would take us humans really long time to do, but it does it multiple times per second. And I think once you've gotten to that point where these are already, you can just take it to the next layer and say, okay, well, how can we, instead of pre-programming and pre-setting that, just enable that to be a function that is done in real time? I mean, we bought 2 GX10s, which are little GTX Sparks from ASUS, and they got 128 gigs of unified memory with a Blackwell architecture graphics card, and they're little mini AI supercomputers. And so when we combine computer vision with an AI orchestration algorithm and a 3D map of the space, the AI is effectively just deciding where and how to move through that. That's our long-term goal. It's not how it is right now. But yeah, I'd say that there's not a material difference between how robots are currently controlled and just having an AI do that stuff in near real time or real time.
Yeah, it's just potentially different every time. It may do it slightly. That's the only difference. It's still the same controls you're passing under the hood.
Yeah, exactly.
Power on, turn, X, like speed on the motor, power, direction, on, off.
Yeah, and there's
Yeah.
definitely going to be certain things, for example, lifting out the basket from the fryer that you want done in exactly the same way each time. And that's where you just go, okay, here's a pre-programmed task, a path that you follow.
Yeah.
But once you got past that point, feel free. And I think that's really where we're going to start to see AI play a material role in creating efficiencies that just couldn't be accomplished otherwise.
Yeah. And then I think that probably leads into the world models, which
Yeah.
a lot of people listening may not know, understand what they are. They just see these fancy demos, which looks like you're just rendering a game in real time.
Yeah.
But that's not what the purpose of them for. The purpose of
No.
those world models is solely for robotics, to
Yeah.
simulate things without having to build 700 kitchens or
Mhm.
thousands and thousands of kitchens in different configurations to see what the best is.
Yeah, actually, we're looking at world models in a really interesting way in the sense that our goal with these robotic kitchens is not to replace restaurants. It's actually to go and solve a problem in the mining sector. Remote kitchens are very, very hard to staff. They incur a massive premium on the cost of employees flying them out there, paying the remote bonus salary. So a salary of a chef in a remote area could be as high as $180,000, where a comparable skilled chef here in Brisbane would be getting 90. So there's a big difference just based on the geography. But once you start getting into those spaces, you get to this place where you're able to really make that kitchen operation repeatable and scalable by breaking it down to its first principles. And ultimately, our goal with all of these kitchens is to get to a really repeatable process that doesn't require a lot of human intervention, so that you can just drop them onto a mine site and feed it with the raw
Be a
materials.
container kitchen, I'm guessing.
Yeah, pretty much. Like that's pretty much where we're heading towards.
So, are you looking at the world models to help simulate the robot in the environments and practice making the meals and different everything like that? Is that what the idea is for your use case with the world models?
The world models are going to be playing a pretty material role. So while we're looking at a mine site kitchen, we don't know all the variables. We don't know exactly what they need. There could be a kitchen that needs 2,000 meals in a 1 hour block, or there might be a kitchen that needs 5,000 meals over the course of a day, evenly spaced out. And so the way that we're looking at world models is in two facets. The first is, how do we actually optimize the layout of the space? Because we are building these modular stations and you can just bolt in as many as you want, we don't know exactly how many stations the user requires. So we're actually building effectively an optimization engine that says, okay, well, give us the high level throughput or the outcome or the desired goal that you want to accomplish. And the AI will use a world engine to simulate by effectively spinning up millions of different options and then testing how those options play out. And then the second part of that is, once we've actually got physical infrastructure installed and we have that world model of that infrastructure, we can actually optimize and tweak the outcome. So if we start with 5 different bits of cooking equipment, a fryer, an oven, a grill, and a boiler, we may be able to only do Italian and maybe some Mexican food. And the robot may not necessarily know how to do Thai food or Chinese, but it's got the necessary equipment. Now you just need to do that training on it. And this is where that world model comes into play again, because once you've mapped that world model, you can essentially just run a very low cost, we're talking hundreds of dollars versus millions, to figure out how to perform these tasks. So world models, I think, are going to become far more prevalent. And especially in these like home robot assistants, like the Optimus and the Neons of the world, my fundamental belief is edge computing will get to a point where they are building the world model as they're interacting with the environment, and they're simulating millions of times, hundreds of times, or thousands of times before they perform an action. So if they're going to go pick up a cup, they'll have done 100 simulations of picking up that cup before they attempt the task. But it might be imperceivable to us as humans. It'll just be happening so fast.
Yeah, there'll be a piece of what the robot vacuums are doing today where they map the house first.
That's it.
Then
Yeah.
go through it. The best case, like the best way to understand the world models for those listening, the way I've seen it in videos and people talking about it is, if you want a robot to learn how to walk on stairs, if you had to go and create a million sets of stairs in all the different configurations, that'd be very costly and very time consuming.
Yeah.
Instead, you can simulate billions of different stair configurations in effectively a game world and get the robot to learn how to walk on all of them. And then once it's done that, it knows how to then walk on the real world. So you give the algorithm to the real robot and it's already done. That's
it.
the use case for it.
That's
In
exactly it.
as simple terms as possible.
Yeah, and I think the most interesting thing about that is when you move a physical, real-world robot into that digital environment, the possibilities of what you can get it to do are unbelievable. We have a Unitree G1. If you've seen that viral video coming out of China of the kung fu robots jumping around and flipping,
They're great show and tell story.
yeah, awesome, right? What you might not have seen is the hundreds of thousands of hours and the millions, if not trillions, of different iterations that those robots went through in a simulated environment to be able to accomplish that in real world. And this is coming back to that physics, the difference between real world physics and simulated physics. The current limitation between where we are going and where we're currently at is the fact that the physics doesn't perfectly line up.
Yep.
And it's very difficult to get that physics element nailed perfectly.
I think that comes down to the way we control things too. So in that world of robots, you're controlling milliseconds and you're using newton meters of torque and current to a motor. And it's going to determine how fast it's moving in. You can make that exactly the same, so I can always land that backflip regardless of what you do. We've got professional athletes at the greatest level. They still can't do repeated tasks, but they just know over repetition, this is roughly what I got to do because how my body's interpreting things.
Yeah, exactly. I mean, human beings, we fundamentally are using same systems. We're using an electrical system to trigger some kind of motor in terms of our muscles, but the precision of our systems is nowhere near the precision of these robotic systems. So no, I think we've been playing a lot with these world environments, and Isaac Sim, if anyone's watching at home and hasn't kind of learned about this before, Isaac Sim from NVIDIA is a great example. There's some brilliant videos that show how you can train these robots. And just 4 or 5 nights ago, I was running a simulation to teach a robot to walk like an old person, kind of hobbled over with a walking stick. And in the course of, I think it was 2 hours, we ran close to 500,000 simulations, which each had 1,000 robots in it. So you do the math at home, but it was quite a lot of robot learning at the time. And I'd say that if we're looking at the future, and the reason I'm going all in on robots right now and that intersection between AI and robots is I always ask myself this kind of question around inevitability. And if we kind of look 5 years into the future, it's almost inevitable. I can't imagine a future that doesn't have robotic kitchens and it doesn't have robotic home assistants, and those things don't exist today. So I think there's quite a lot of flux with how AI is disrupting the world, and everyone's kind of looking at how do I take what this technology is and do what I've been doing. And arguably, that might not be the best course of action. You might want to kind of like look forward and say, what is absolutely going to be, no one can, with a straight face that has any understanding of where tech is, can deny that this is going to be the case and then start building for that.
Yep. And we know that's the direction everything's going, but we don't know how fast, what leaps we don't even know about yet, and they need to happen to get to the level, because everyone keeps saying like artificial general intelligence is going to be the linchpin to everything. There's no clear definition for what that even is across the leaders of the industry to say, yep, this is the one last breakthrough we need, and then all of this is possible. You've got two competing directions with Jan LeCun and the Demis Hassabis on the two leaders effectively of the AI movement at the moment, and they both have a completely different way that they think it's going to happen.
This comes back to my skepticism around the marketing. And I think that there's so much hype and everyone's using their own proprietary language and their own definitions, and they're effectively making their own goalposts as they go. And ultimately, I'm a little more pragmatic in the way I'm viewing these things, in the sense of look at the immediate world and look at the broader world around you and say, well, where is the technology actually having an impact, and where will it most likely have an impact? And I think that while the tech is moving at an astronomical rate, the rate limiting factor is still the people. And ultimately, at the end of the day, like we see this every day with our clients, we can build anything that they're asking for because typically they just can't imagine these systems being able to accomplish what they can. But the rate limiting factor is how do you make sure that they're held accountable? How do you make sure that people are in the loop and can actually understand what's going on? And so the human is still the rate limiting factor for the tech, as it always has been.
Yeah.
But it's actually something we need to focus on right now because this is the one technology in human history that has the most impact on our fundamental societal assumptions and will materially change what our civilizations look like into the future. Just in the last week, we've seen that Anthropic's gone through this whole moral kind of saga with the Department of War in the US. And the irony of this is that the US intervention and US excursion into Iran is using Claude for target selection, and it's using this technology. And so that's kind of like where I look at it and say, okay, the tech is actually making a material impact now. Oh, my AI has decided a close-up is
That's
what
an
we
important
need.
statement you're about to make.
That's exactly, yeah, zooming in on this one point. But I think when we're looking at how this tech is fundamentally changing our real world, I think the change is going to be a lot slower. And I don't see a scenario unless we completely throw everything up into the air, all of society's norms, and just discard any assumed knowledge. It doesn't really matter if AGI is accomplished or not, and the goalpost is almost already accomplished. It can do so many things.
It's going to be slower, I think, than what everyone thinks, because I think the consensus among those who aren't in the space are we're just going to wake up one day and there's going to be a robot at every house.
Yeah,
Like,
no,
it's not like a movie.
no.
It's they're going to be $100,000 to get one of these into your house. The really rich people are going to have it first. They're
Yeah,
the new adopters. They're going to get the shiny tools. They're going to replace their assistants and maids or whatever they have. Then over time, it'll trickle down. The same way you have technology in cars. An
yeah,
S-Class Mercedes 10 years ago or 15 years ago had lane assist.
yeah,
Almost every car has lane assist now.
yeah.
Same concept. It's just a tool that gets rolled out. It's just going to be the accessibility to it is going to take longer.
Yeah, I think and this is some of the stuff that we do with the AI community here in Brisbane, is we have discussions on these kind of topics, and it's important. And I think we all have a civic duty to have these discussions, not just on podcasts, but at a barbecue and around the dinner table, because this is not going away. These questions need answers, and we need to be informed and have actually given it some thought. But ultimately, we're getting to this point where we're starting to see how this tech is fundamentally eroding all of those assumptions that we hold near and dear. And I think you're bang on right. And ultimately, the big thing that I advocate for at the moment is make sure that we are looking at this technology not as who has access to it first, but how do we actually want it to be deployed? Otherwise, we'll end up in this dystopian nightmare where the people with resource and people with wealth get access to these astronomical capabilities that everyone else has no chance of even getting a hold of. And the problem with that is that this is that kind of technology of the more you engage with it and the faster you adopt it and the better you leverage it, the faster you move. It's an accelerator. And it's the equivalent of two cars on a starting line of a racetrack, and one puts a pedal to the metal and the other one waits 20 minutes and then puts the pedal to the metal, and they wonder why one finished the line and lapped them 10 times. Like it is very much that case. The only difference with that analogy is that the further down the racetrack you get, the faster the car is going. It's constantly building inertia and momentum. And so I think we're getting to this place where we really need to figure out what is the best way to do this? I know the AFR and I think it was a central bank came out today and said, we need AI capabilities here. Otherwise, the Australian economy risks hollowing out its entire value because we're effectively outsourcing these tasks. But the tooling and the way that we're doing it is by using these tools coming from the US. So we're just taking our money from people here, replacing headcount and sending it there.
Yeah.
And I mean, no wonder there's
Nothing's
trillions of
happening,
dollars being invested in the States on this. It kind of makes sense.
Yeah, and it's the way everything's going, and
Mm.
like probably in your community there in Brisbane, because everyone's invested in AI, you're getting a different viewpoint compared to what the general public is. And I haven't
Yeah.
spoken to many general people who don't know anything about it. Like my dad, just I want to be able to talk to the phone, so I set up Google Gemini for him. And
Yeah.
now he's got an AI assistant he can just talk to all day. Like that's his exposure to AI. He
Yeah.
doesn't know anything about the robots or what's coming, and not many people do because they're not paying attention to this. There's just too much news and
This
too
is
much
it.
marketing hype to come up. Like you got jumping robots doing kung fu on the stage, and that's what everyone's going to be talking about for the next week, compared to the GPT-4 model and its new capability, or
Yeah.
what it couldn't do compared to 5.3, and that came out last week. And then 2 days later, something else will come out and over eclipse that.
Yeah, and I think like human beings are incapable of fully comprehending what exponential change looks like. We have a set amount of memory in terms of things that we can hold in our frame of reference at any one point in time, either actively focused on or just, hey, this is the stuff that I'm aware of. The challenge here is that there is so much change happening so quickly with such massive impact that even the folks paying attention are overwhelmed. I think your analogy of the dam releasing but it's releasing on almost a daily basis now. And so I see this year being a real inflection point. I think the tech is now at a point where we are going to start to see material choices in business being made around downsizing headcounts. We've already started to see early indications of this with massive layoffs from large tech companies already leveraging this tech.
Yeah, but those layoffs may not necessarily be because of the AI as well. They did
Yeah,
overhire over the past few years as
absolutely.
well, which they shouldn't have done just post-COVID potentially
I
too.
I don't disagree. I think though that when I read a lot of commentary on this, especially in business forums like the AFR or in keynote presentations at Davos and these kind of things,
Hmm.
there is a very specific way that most business leaders are looking at this technology, and it is very much around a fiscal
Yeah,
cost equation. It's almost a zero-sum game, and it's a really, in my opinion, quite a dangerous perspective. And it's quite an isolationist perspective. If you are only making decisions based on you and your best outcomes, then who's making the decision that's best for the greater sum?
yeah,
Otherwise, we're just like,
yeah. They're making decisions for shareholders.
that's it.
We
But
may not be able to increase our revenue X% this year, but if we reduce headcount, we can achieve that target through the gap. And we
but
assume that AI will keep us as productive, if not more.
exactly.
That's the gamble they're taking.
Yeah, and
But
I
you're right.
think
Yeah, there's missing a whole humanity side.
then there's a really dangerous kind of setup being kind of laid out right now in it at a macro scale. Because if every business leader is making that decision of, hey, I can maximize my return by reducing headcount, we're going to only need a shock. And I think if the Iran conflict happened 12 months from now, and we had this seismic shift in one of the fundamental pillars of our society, which is transportation cost and oil, with large numbers of layoffs, not many people in work, an increased burden on government expenditure from unemployment, these kind of like this is a nightmare scenario brewing that not many people are paying attention to because they're looking at their slice of the world and not making a decision of, hold on, maybe I should just redeploy people and grow the business and grow the opportunity and expand into new markets instead of just stay in my lane and cut headcount. And this is something we advocate for pretty aggressively when we're doing our kind of consulting work is we can absolutely make most of your team redundant. You shouldn't do it though. You should absolutely leverage that team and turn them into super weapons to do other stuff. So I think we have a failing in my opinion, in our public discourse at a government level around the fact that we're not thinking long term. We're not looking at the whole board. We're looking at individual pieces on the board and trying to maximize the outcome for that. And it might be at the cost of the board. And this is where my work with the Queensland Air Hub, this is how we're kind of trying to advocate for, hey, everyone needs to be in the driver's seat and you've got to leverage this technology, but do so in a responsible way. And my hope is that market forces will naturally gravitate towards organizations that aren't optimizing for these negative societal outcomes. They're optimizing for reinvestment into human beings, because at the end of the day, money doesn't have a life. Like, we all have flesh and blood and loved ones that we care about, and no one likes to see their friends unemployed or their partner unemployed, and just the condition, the living kind of environment that creates, the life that we lead in those scenarios is not great for anyone.
No, and I completely agree with what you said there. It's we need to look after each other, and we need to make sure we can help everyone do better.
Exactly. And look, I think this technology is enabling us to do things that used to be impossible. My father in 2023 lost the ability to speak. He was diagnosed with motor neuron disease. And I leveraged AI voice cloning to bring his voice back. And then he used that tool as he physically lost the ability to move due to the disease to communicate with people. And we saw these incredible moments where he would record a voice snippet using his AI voice and then post it into a group chat that had gone dead because he can't type anymore, or he couldn't type very much. And those chats became alive again, and they started engaging, and they all caught up again. Like, the impact of this tech is very much about how we want it to be leveraged. And it's important for us to factor in morality and ethics in these equations, not just the bottom line.
Yeah, I don't think enough of that is talked about, because it's all about how fast you can do your work.
That's it.
And that's what most people are worried about day to day. Like you said,
Yeah.
you're all in your own silos. We're trying to figure out how do we make it better for ourselves, not
Absolutely.
only trying to make it better for everyone else.
That's exactly it. And at the end of the day, a rising tide lifts all boats. If everyone is doing better, then there's more economic activity, everyone is benefiting, and ultimately the end result is that we move forward collectively. And I think we run the risk of, if only a few people get to run ahead. I'm always reminded of the story of the mob of Alexandria in ancient Egypt, where the Egyptians used to have a huge trading network back in the day. And every time a boat would come into the Egyptian port in Alexandria, they would go in and they would search the boat for manuscripts. And as a result, they had this incredible repository of documented knowledge, the Library of Alexandria. This story ends in a way that I'm hoping the AI story won't end, which is that a mob grew tired of a lack of access and a lack of equality and effectively stormed and burnt it down. And I can see a real possibility, if we don't chart a course that is human-centric, that we might see a scenario play out where the fabric of our society is just torn apart and we don't really know how to sew it back together.
Yeah, and I don't think anyone wants to go down that path. There's not enough public discourse on that aspect of it without looking like fear-mongering at the moment.
Yeah, exactly. And I think there's two sides to this equation at every turn. And normally I try to have these as structured debates without the hyperbole and actually backed up with real tangible research and really great examples that people can latch onto. In fact, I'm catching up this afternoon with someone, and we're talking about hosting a debate on the role of AI in government, in terms of what would AI look like if we leveraged it for policy decision making, and we're going to hold a debate on that, and we're hoping to hold it in Parliament House here in Queensland. And we just think that this is one of those things that if we can pull something like that off and get that discourse started, we might actually be able to get the conversation moving in the right direction.
Yeah. Well, I wish you luck with that.
Thank you.
We'll probably wrap it up then, just conscious of the time. If anyone wants to find out more about yourself in the kitchens or what you're doing with the AI Hub and everything else, how can they do that?
Yeah, so you can find me on LinkedIn. It's Alexander Cohen, or head to our website, 3hatrobotics.com. And if you're interested in working with us to effectively implement AI in a responsible way in your business, our consultancy is scopego.co. So thank you very much for having me, Anthony. It's been a genuine pleasure, and I'm looking forward to hosting you here with some robotic food by the end of the month. Until then.
That sounds good.
Yeah.
Well, thank you. And yeah, thanks for joining me on the Dev Ready podcast.
Thanks very much. Catch you later.
Thanks. Bye.